This is the solution of the previous activity, where you have to start from the previous activity, so activity number 3 again, but this time we are going to put some logs from the Arduino to the LCD screen. And so first of all, we are going to initialize the LCD screen. So I'm going to include the liquid crystal library, so liquid crystal.h with angle bracket, and then add some define for the pin. So LCD RS pin, which is A4, and then LCD E pin, which is A5. And let's actually copy this 4 more times with D4, D5, D6, D7, which are pins number 2, 3, 4, and 5. And so we can now create the LCD object. So let's create it here, liquid crystal, let's name it LCD again, with all the pins, so RS and then E. So make sure you respect the order here, okay? That's very important. And then let's go here, D5 and D6 and D7. Okay, now in the setup, so we have serial.begin. We can also do lcd.begin with 16 and 2. So here again, the order doesn't really matter, because as soon as the LCD is started, well, you can start to print something. And now, well, we're going to use the LCD here. So let's say that when we send the counter, at the same time we do serial.println. So just after that, maybe we do lcd.clear. Okay, so we clear the screen from anything that was on the screen before. We do then lcd set cursor 0, 0 to go back to the beginning of the screen, and we say, let's say, lcd.print with sent counter. Okay, and let's do lcd.print with the counter. So here, as you can see, if we do a print and then another print, well, the cursor, it starts from 0, 0, and then it's gonna go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we just have 2 more characters that are possible here. So basically, as long as the counter doesn't reach 100, we're gonna get all the characters. If you want, you can also do lcd.set cursor with 0 and 1. So basically, you're gonna print that on the first line and that on the second line. Okay, let's keep it like this. And now, when we receive something here, well, for example, what we could do is directly when we receive a command, just print that command. Or we could do a different LCD print for each command, okay, with a custom text that we want. But here I'm just gonna do this, lcd.clear. Okay, if I don't do lcd.clear, everything is gonna be written on top of what has been written before, but it's not gonna remove the other characters. So you may have something that is quite weird on the screen. So that's why when I write something here with the logs, I'm gonna do lcd clear and lcd.set cursor 0, 0, lcd.print cmd. Okay, so whenever we send something or we receive a reset command, the screen is gonna be cleared and we're gonna get the new log that is printed. So let's try that. Okay, I'm gonna upload the code first. Let's name it activity 4. I'm gonna also save this file, this Python file, as activity 4 as well, even if that's the same code. And then let's start the Python program. Okay, so serial OK, and you can see here send counter. Okay, you can see, and we have reset counter and then send counter because, well, it goes very fast and we just received it. We'll just receive the command before we send another counter. Okay, you can see up to 20 and then reset counter, send counter. Okay, so you can see basically what's happening from the Arduino. I'm gonna kill this. And so as you can see, this system is not the best ideal system because, for example, here on the Raspberry Pi, the logs that we see here are kind of better. But that's always something you can do to debug a little bit. And you can see also that it's not just about debugging. Now you can see that you can control the LCD screen directly from your Raspberry Pi, okay? Because here you just send some text and you can print that text on the LCD. So you can already control some Arduino components from the Raspberry Pi going through the serial communication. And that's the end of this activity number 4.